Okay. So it says 3 kings from yesterday. 3 kings. So we need to have exactly 3 kings. So can we have another king? No. So we can have 3 kings and 2 not kings. They just have to be anything but not kings, right? So whenever you have not enough cards to make up the hand, you have to do whatever it says and then whatever left of not kings. So this would be 3 kings I need and 2 not kings. Because I can't use that 4th king because then I'd have 4 kings and I only want 3, right? Only way to guarantee getting kings is choosing from kings. There's 1 king in every suit. There's 4 suits. So there's 4 kings. So we do 4 kings, choose 3. It's a combination because it's cards, and cards are always combinations. The order doesn't matter. Times not kings. So if there's 4 kings in a deck of 52, how many are not kings? 48. So we do 48 C2. And what do we get? All right. Then we have 4 aces. Still not 5 cards though, right? So we need 4 aces and 1 not ace. Really bad English, but that's how I roll. 1 not ace. So we need 4 aces. How many aces are there? 4. There's 1 in each suit. So you're going to do 4 C4 times 1 not ace. So there's 48 cards that aren't aces. Choose 1. So it's 48. Five cards of the same suit. So people say, well, which suit? It doesn't matter. Pick a suit. Figure it out. So if we had 5 cards of the same suit, let's say we need 5 diamonds. Okay? We'll have 5 diamonds or 5 hearts. Worst heart ever. Or 5 spades. Or 5 clubs. Now there's 4 suits in the deck. There's 52 cards in the deck. So if I do 52 divided by 4, each suit has 13 cards. Okay? So I have 13 diamonds. Choose 5. Or 13 hearts and I choose 5. Or 13 spades and I choose 5. Or 13 clubs and I choose 5. Now, why am I adding them for or and not just anding them and multiplying? If I said and in there, then I would say I have 5 diamonds and 5 hearts and 5 spades and 5 clubs. Yeah. Right. So if you had 5, 5, 5, 5, you'd actually have a hand with 20 cards in it. It'd be really hard to hold. You'd have a hand with 20 cards. We don't want a hand with 20 cards. We want a hand with 5 cards. So we're either going to get 5 diamonds, or we're going to get 5 hearts, or we're going to get 5 clubs, or we're going to have 5 spades. So 13 choose 5 times 4 is how you could write it as well. And what do you get? 5,000? Okay. You guys try 2 and 4. The answer's over there. Example 6. "12 adults and 18 kids are on the prom program planning committee. A smaller group of them, 5 only, so a little subcommittee, needs to decide on the themes. How many ways can this smaller group consist of at least 4 adults? Does this group have anything special if you're picked first, second, third, fourth, or fifth? No, you just get to sit together and decide on the theme. Okay? So we know it's a combination. And any question below this is going to be a combination. The key here is at least 4 adults, at least 4. Okay? So if I said at least or at most, you're going to have to do cases. Okay? Now let's think about it. I always think about it in terms of money. If I need at least $4, do I need 4 or more dollars or 4 or less dollars? 4 or more. So if I need at least $4, I need 4 or more. If I need at least 4 adults, I need 4 or more. We're going to top out at 5 here because we can only have 5 people on the committee, right? That's what we'll do. So method 1, figure out each situation separately. So there's 2 methods. There's one where we figure it out separately or we figure out the complement. I'll show you the complement when we get to one that's actually helpful with the complement. This one's better to just figure it out directly. So at least 4 adults means 4 or more. So we're going to do a case of 4 adults or a case of 5 adults. But just like the last card questions we did, we need to, every committee needs to have 5 people, just like every hand needs to have 5 cards, correct? So if we have 4 adults, we need 4 adults and 1 not adult. Well, in this case, what's the not adult? Kid. So we need 1 kid. Or 5 adults and 0 kids. Do we have to write the 0 kids? No. Once you have this laid out, the rest is really easy. You just use the numbers they gave you above. We need to choose 4 adults from how many? Yeah. And means multiply. We need to choose 1 kid from 18. And that's our 1 case. Or means plus. We need to choose 5 kids, or 5 adults, sorry, from 12. It doesn't go down to 11 or anything like that because these are separate cases. It doesn't go down to, some people try and make it go down to 8 because I've used up 4 adults already. No, this is 1 case where we're going to get a group that we need, or this is another case. So it just starts fresh again with you have the full number of adults and kids again. Okay? So we get 12 C4 times 18. 8,910 different groups that we could form for 4 adults and 1 kid. Or 792 different groups we could form with 5 different adults. Which is 9,702. For today, we're just going to look at doing it directly. Do directly what it says. And then tomorrow I'll show you how you could do the complement in some cases and it would make it faster. When I teach both at the same time, I lose people. Like they'll either get one or the other and they're like, no, I can't do this. I can't do, I'm done. I'm stopping. Okay, so we'll just do the method 1 today and I'll show you method 2 tomorrow when you've gotten method 1 down. So this is another group of 5, but we need at least 1 adult. At least 1 adult means 1 adult or more, or 1 adult or less. At least $1. If you need at least $1, you need $1 or more. So we're going to need 1 adult or more. This is one where the complement tomorrow will be a lot faster because 1 adult or more means you're going to need a case with 1 adult or 2 adults or 3 adults or 4 adults or 5 adults. A lot of cases, right? So we're going to have 1 adult or 2 adults or 3 adults or 4 adults or 5 adults. Now what do I have to remember to still add to those? The kids, because sometimes I don't have groups of 5, it's just the adults, right? So 1 adult and 4 kids, or 2 adults and 3 kids, or 3 adults and 2 kids, or 4 adults and 1 kid, or 5 adults. Because in the end, each case needs to have 5 people for the subcommittees, right? Once you have that written out, the rest is easy. You just literally just fill how many adults there are in front of the adult one and how many kids there are in front of the kids ones, right? So 12 adults, and I choose 1. And 18 kids, and I choose 4. Or 12 adults, and I choose 2, times 18 kids, and I choose 3. Or 12 adults, and I choose 3, times 18 kids, and I choose 2. Or 12 adults, and I choose 4, times 18 kids, and I choose 1. Or 12 adults, and I choose 5. So there are 133,938 different committees I could make that contain at least 1 adult. Okay? The only difference is at least or at most. That's the difference. So if it's at least something, you do that or more. If it's at most something, you do that or less. The catch with at most is remember that at most, say if it's at most 2 kids, you could have 2 kids or 1 kid or no kids, right? The catch is everyone forgets about the 0. Okay. So we're going to look at most 2 adults. So that's 2 adults or less. At most $2, I need $2 or less, right? So see if you can do it. Okay. So we need 2 adults or 1 adult or no adults, which means 2 adults and 3 kids, or 1 adult and 4 kids, or 0 adults and 5 kids. Do I have to write the 0 adults part? It's good to have it so that you remember to do the just 5 kids, though. Now, we're going to have 12 choose 2, times 18 choose 3, plus 12 adults choose 1, times 18 kids choose 4, plus 12 adults choose nothing. So I'm not going to write it. And then 18 choose 5. What do you get for an answer? Annie? 99,000? So does it make sense, at least at most? And the key thing here is that the subcommittee had no special jobs, right? There's nothing more special if you were first or fifth, so it was a combination. If they asked this question and gave all 5 people jobs, then instead of C's, you'd have P's. That's the only difference. Okay. The student council decides to form a subcommittee of 5 council members. We need a 5 council member subcommittee to look at how funds are raised should be spent on the students of the school. Nothing more special if you're the first or the fifth council member, second or third, fourth, right? It's a combination. There are a total of 11 student council members, 11 total, 15 males and 6 females. So if we don't get anything specific, like we need this many females or this many males, we would just do 11C5, right? If we just wanted to pick a subcommittee, be 11C5. The moment we say specifically about males and females, then we have to actually use the males and female part, okay? So how many different ways can you form the can the subcommittee consist of exactly 3 females? So if we want exactly 3 females, we're not going to get cases. There's just one case. Exactly 3 females, which means what? 3 females and the 5-person, 2 male. It's a 5-person subcommittee. So I need 3 females and 2 males. I know if I say exactly 3 females and 2 males, I'll get a whole bunch of you getting it correctly. I know, so if I see that on the diploma, I'm like, yes. If I see on the diploma 3 females, but they don't tell you the number of males, I get a little cringy because I know that I'm going to drop, some of you guys are going to drop off because you're going to forget that you need to make it be 5 people, right? You're going to forget to add the 2 males. All right, so females from females, 6C3, and multiply 5C2. It's 200. Then we'll do B. At least 3 females means 3 females or more. The moment you have at least or at most, you have cases. So 3 females or 4 females or 5 females. Sometimes you actually can't do the 5 female case or something like that. If they originally only had 4 females to choose from, you wouldn't be able to do the 5 female case. You couldn't have 4 females choose 5, right? So that case would be kicked out. So we have 3 females and 2 males, 4 females and 1 male, and then 5 females. So 6C3 times 5C2 plus 6C4 times 5C1 plus 6C5. I want you guys to do 8 to reality. Consider a standard deck of 52 cards. How many different 5-card hands can be formed containing at least 1 red card? At least 1 red. So it'd be 1 red or 2 reds or 3 reds or 4 reds or 5 reds, right? You're all looking at me like you don't believe me. Yes? No. At least 1 red. Okay, I'll just do it. So at least 1 red means 1 red or more. So 1 red or 2 reds or 3 reds or 4 reds or 5 reds, which means the opposite of red is, thank you. I should have used the black, oh, I could use red and black markers. It would have been so much fun. Yet it's blue and black, but that's good. Okay, 4 black, 3 black, 2 black, 1 black. So it's going to be 26C1 times 26C4 plus 26C2 times 26C3 plus 26C3 times 26C2 plus 26C4 times 26C1 plus 26C5. Fun, right? So there is a complement, which is what I was talking about. When you see like a ridiculous amount of cases, you can do the complement. The complement is, what you do is you take the total, so it's 52C5. That's the absolute maximum card hands in the world, right? From the deck of 52 cards. And then you subtract off the opposite of that. So at least 1 card. What's the opposite of at least 1 card? No cards. So you just subtract off, or sorry, no red cards. So you'd subtract off 0 red and 5 black. So you just go 52C5 minus 26C5. And it will get you the exact same answer.
What?
Yep.
Why don't you just teach us this?
Because some ways it's shorter to do it normal. For example, like if it's at most 1 king, well then you do 1 king or no kings, you'd have 2 cases, right? You only do the complement when you would have like a whole bunch of cases doing it normally. Because if you only have a couple cases doing it normally, the complement's going to have a whole bunch of cases. So you just have one way's better sometimes and one way's better the other times. So it depends on if you're writing out a whole bunch of cases, guarantee you the complement's better. When I teach them at the same time, though, people are like, I have no idea what you're doing. So don't be mad. It would just do that. Okay. And then at most 2 kings.
On the diploma, is it all multiple choice or is there?
There's 28 multiple choice, 12 numeric response. There's 40 questions.
Oh.
A lot. But it's worth 30 now, so that's good. It used to be 40 questions worth 50. So each question was worth more than 1% of your mark. Now that was scary. See? So much better now. Positives. Okay. Example 9, we're going to look at this. This one, you have to pay close attention to me, please, because there's going to be 2 that are similar to this. During a PB hockey tryout, all the players met on the ice after the last practice and shook hands with each other. How many people shake hands at once together? I can shake it by myself too, but yes, 2 usually do. 3 is a little awkward. You're like doing a triquetra of handshakes. 1, you're lonely. I guess, but it would be 2 hands still, whatever. So they're shaking hands with each other. That means 2 people are shaking hands together, correct? Now, if I said, not this question, say I said at the hockey tournament, so strange, at the end of the hockey tournament, 100 players shook hands with each other at the end. They all just met in the middle of the ice and shook hands, okay? How many ways could that happen? Well, there is no like order to the handshake. Like just like if I meet you first, like if I like really get in there first before you do, still the same handshake, right? Like order doesn't matter. Like if she gets in there fast, still the same handshake, okay? Handshakes are always combinations. Order doesn't matter. Like it doesn't matter who's fastest to the handshake. It's still a handshake. Okay, so all we would do is we'd have 100 people and we'd see how many at a time to shake hands. 2. It would be 100 C2, and you'd have all the different ways that those people could shake hands with each other. I know everyone really cares about this, right? But yes, that's how it is. So instead of giving you the number of people and determining how many handshakes there are total, this question tells you how many handshakes there are and asks you how many players that there was. So during a PB hockey tryout, all the players met on the ice, the last practice, and shook hands with each other. Algebraically determine the number of players who attended the tryouts if there were 300 handshakes total. So what did we do to get the number of handshakes? We took the total number of people, we chose 2 at a time, and we got the handshakes, correct? Well, right now, we don't know the total number of people, so we're going to put an N there. So it's going to be NC2 equals 300. Do you see how this is very similar to the 2 questions I gave you previously with the NC2s? It's the exact same thing. Just instead of it equaling 6 or 10, it equals 300. So could you go 2C2, 3C2, 4C2, 5C2, 6C2, 7C2 until you get to 300? Absolutely, you could. We're going to do it algebraically, but you could do that. You mad calculator, go. Yeah. If they say where did dude make a mistake, you'd be like, he didn't use his calculator, that's where he made a mistake. But that won't be an option, so we have to know how to do it the long way too. So it'd be n factorial over n minus 2 factorial equals 300. Bring your 2 up. So we're going to get n minus 1, n minus 2 factorial over n minus 2 factorial equals 600. Cross these off, and we have n squared minus n. N squared minus n equals 600. What's that going to be? Multiplies to give you 600 and adds to give you -1. 25 and 24. So n minus 25, n plus 24. So n equals 25 and n equals -24, which is not possible to have -24 people. So my answer is 25. The other one I wanted to go over quickly is if they say I have 10 teams and they play each other once. How many teams play at a time? 2. So you do 10C2. If they played each other 3 times, you do 10C2 times 3. If they played each other 20 times, you do 10C2. I take my 10 teams, they choose them twice, then times by however many times they play each other. 10, 20, 30. Other thing, if I give you dots on the outside of a, just dots, on the outside of a circle, let's say, and I asked you how many triangles can be made? How many triangles can be made? Is this a different triangle than this? Than this? So does the order in which I pick those 3 pieces matter? No. So I count how many I have. 1, 2, 3, 4, 5, 6. I have 6 vertices that I could join, right? And I choose how many at a time to make a triangle. And I have my answer. Okay. There's that one. And then this is your assignment.